This is the STS 133 interview with Mission Commander Steve Lindsey. Steve, tell us about the place that you consider to be your hometown and what it was like growing up there. How that place influenced who you've become.
Well, I was born and raised in Temple City, California, which is a small suburb of Los Angeles. And I think the way it influenced me, it was even though it's a suburb of a very big city, it was kind of a small town kind of life. We had, you know, a couple elementary schools, one high school, one junior high, and so everybody knew everybody, a fairly small school. I think it influenced me in that it was a small community with a lot of parents that were interested in what their kids were doing, and teachers that were as well. And the schools were good. Learned a lot from the schools, learned a lot socially as well as intellectually, and was encouraged from the very beginning from all the people that I knew to, you know, go off and do whatever it is I wanted to do, just work hard for it. So I think kind of small town values and ethics and drive were taught for me at a very early age, and I think that kind of set the course for me from then on.
Okay. Did you have you had occasion to see that area from space on any of your past space flights, and if so, tell us about maybe the first time that you can recall that happened.
Well, I've pretty much every flight I've been on, I've seen Los Angeles from space. It's pretty hard to pick out exactly my community. I've gotten the binoculars on it a few times to try to pick out you know, landmarks that are near my house. So it's really neat to see it from space. It's actually any place on Earth, the first time you see it from space is something I'll never forget. I remember on my first flight, during ascent, we climb up basically heads down, so we're going in upside down as we climb out of the atmosphere. But we're nose high, so all you can see is the space. So you're seeing blue, 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 and then black. Mm-hmm. But about 6 minutes or so into the flight, we actually, or a little bit before that, we actually do a roll to heads up. So we transition our communications from a ground site to a satellite. And so we roll the heads up so we can get antennas on it. During that roll to heads up is really the first time you get to see the Earth from space, is, you know, just right in the beginning of ascent. And I will never forget that first roll. It rolled, I was sitting in the pilot seat, it rolled my way so I could see the Earth coming up. And seeing the Earth from space for the first time, that was very memorable. So, you know, things like your hometown are very memorable, but just seeing the Earth and the beauty of the Earth and that it's actually round, like they say in the geography books, it really is true. And that's something I won't ever forget.
Every accomplishment begins with some form of motivation. You've been an astronaut for more than 10 years. Talk to us a little bit about what things specifically motivated you to pursue this line of work.
Well, probably a couple of things. Growing up, I think one of my big role models was my father and my mother, but my father professionally was an engineer. My father started out as essentially in the Depression. They were more or less sharecroppers and never owned their own land, and they farmed. And he went off to, you know, went to a one-room schoolhouse, did graduate from high school, but he was, you know, working as a truck driver and a farmer, and then he got drafted, went to the Korean War, came back on a GI Bill, and got his engineering degree, to make a really long story short. And so he's an electrical engineer, and I think watching him, his life and him pursuing that gave me an early interest, I think, in math and science, and in particular wanting to pursue engineering. So I had pretty much decided early into high school that I kind of wanted to be an engineer. But the other thing I really wanted to do is I wanted to be a pilot. I wanted to fly airplanes, I suppose, like a lot of kids thought that was pretty cool. But I thought it was pretty cool, wanted to fly airplanes. And I got to thinking about, you know, what can I do that will allow me to pursue both of those things? And so I obviously need to go to college and get an engineering degree, but I also need to figure out, well, how am I going to fly airplanes? I can't afford to pay for flying airplanes. But so then I was on actually a high school trip when I was, I think, a sophomore in high school, and we were with a group of kids. When I was in the band, and we traveled to Colorado Springs, and we went and visited a place called the Air Force Academy that I had actually never heard of, and went and saw that and learned it was an engineering school, you know, very difficult engineering school, but also learned that, you know, that you graduate as an Air Force officer, and if you're qualified and if you do well in a school, you have an opportunity to go to pilot training and learn to fly airplanes. So I thought, well, this is perfect for me because it does the two things that I really want to do. And so I went to the Air Force Academy. I was fortunate enough to get selected for that and graduated from there, and then I went to pilot training, and so then I started flying airplanes, and I was operational fighter pilot for several years and an instructor pilot, and I really enjoyed that. I really enjoyed the flying. I've been flying for, I don't know, almost 30 years now, and I still love it. But after I'd been doing that for about 4 years, you know, I was thinking, well, I'm doing a lot of flying, but I haven't had a chance yet to really apply my engineering background and my love of math and science, and how can I do that? And talking to some folks, I kind of learned about the job of being an experimental test pilot. And an experimental test pilot, what they do is their job is to translate between the engineers that are developing and building the aircraft and the systems and the operators that are using the systems. Well, I've been an operator, so if I could be a test pilot, then I can help bridge that gap, and I can actually apply my engineering education to flying. And so I applied for and was fortunate enough to get accepted by the Air Force to go to graduate school and then to test pilot school. I completed that course and became an experimental test pilot, where I was again applying engineering and flying together and doing a job that was just a fantastic job. So I got through that process, been a test pilot for several years, and realized, and kind of wasn't shooting this way, but kind of realized that, well, you know, if I were to apply to the astronaut program, an astronaut's job is very similar to this. You know, you combine flying and technology and science and engineering, all of those things together. You just do it a little bit faster and a little bit higher than flying airplanes. And so I decided, well, what the heck, I'm qualified, I might as well apply. Worst they could say is no, which I figured they would. And so I applied, was fortunate enough to get selected for this, and here I am. So pretty much my whole career I've been able to combine my education and flying, the two things that I love, together. And so that's kind of a really long answer to how I ended up where I am today.
Specifically about the experimental test pilot portion of your career, was some part of wanting to do that the opportunity to discover? I mean, because basically you're doing something, you're testing things, and you may be the first to put your hand on.
Yeah, absolutely, and it's really exciting to do the first of something. And you know, the first time you test this system, or the first time you test this weapon, or the first time you take the airplane to this speed or this number of Gs or this altitude and things like that. That's exciting, but also what's exciting about it to me is you do all of this work beforehand. You don't do this haphazardly. We don't just go out and, you know, take an airplane, okay, let's go to 800 knots and see what happens. What we do is we do a very calculated build-up approach to that. We start out in a wind tunnel. We look and see, how is this airplane going to fly under these conditions? What are the things we need to be concerned about? We worry about the flying qualities, in other words, how that airplane handles. Can you fly it? Is it controllable? At what speed will things start to come apart? And you do this, all these calculations and experimental and analytical development and testing before you actually take the airplane out and take it to that endpoint. You know, if you're going for a, let's say, a Mach 2 test point, you don't start it going at Mach 2. You build up. You may go to Mach 0.8 and Mach 1 and build up. So for me, the interesting part was not just being the first one to do that, but it's putting it all together. It's developing a flight test profile, tying the engineering and the science into the flying, and bringing it all together so that you can do it safely and effectively. And so, because the ultimate goal, in my mind, as a test pilot was to not get surprised at the end. Now, unfortunately, the nature of the game is I often got surprised at the end, but you try to avoid doing that. And so it's that process, and in the process of doing that, also working with a team of folks with very diverse backgrounds to watch this team come together and figure out how to do these complex activities and do them safely and successfully. So it's really the process also that was I really loved about doing it.
Tell us how you would characterize the value of education in your life, and what it's meant to your life.
Education is critical. No matter what you do, your education is critical, because what education does is it enables you to do things in the future. You need to have that foundation of education, and it's really for two purposes. Number one, in my job, having the engineering and science background enabled me to take it to the next level and do those things I need to do. And for example, when I'm on a space flight and working on an experiment or doing something operationally, to understand the science and engineering behind it, so that when things don't go as expected, you can change your course of action, or you can understand why and know, okay, well, if I go back and do it this way, this should work, or I'll try this. So that piece of education is really important, because you got to have the background, no matter what you're doing, to know how to do it. The other thing that's important about an education, I think, is it usually happens early in your career, high school, college time frame. And when you get that first degree out of college, it's a difficult thing to do. You have to go through typically a 4-year plus process to get there. And what it does is it establishes that you can start something and finish it. Start something difficult and complex and finish it. And it sets a course on your life or a track record that you can start and finish something. So for an employer, obviously looking at that, saying this person has graduated, so that I know they can go through this complex task and complete it. It also sets in your mind that I'm going to go here, I'm going to set a difficult goal, and I'm going to achieve that goal. So for both of those purposes, education, I think, is very important. And it's the key, and it's the foundation at which you start building any kind of professional career.
Everyone on this crew has been to the space station, including 3 crew members who've completed long-duration flights on ISS. How much of a benefit will that be to having their combined experiences to successfully completing this mission?
Well, we do have a lot of space station experience. We're probably one of the more unique shuttle crews in that, number one, we're all experienced. We've all flown in space before, and 3 of us, Mike, Nicole, and Tim, have done long-duration flights on space station, so they're intimately familiar with space station. And actually, all 3 of them flew very recently up to space station, and so they know the ins and outs, and it's very valuable. That will help us a lot in this flight. The danger of having an all-experienced crew is we are all experienced, and so we have to really watch and make sure that we're confident, but don't get too confident. And that's true of anything. I mean, you may not have heard this before, but the most dangerous aircraft is one that has 2 instructor pilots in it. The more experience you have, the more you have to watch out for complacency and things like that. So the experience is invaluable. As we're going through training, we're figuring out how to do things. Each one of us can actually be up there and visualize how this is going to work before we get up there, because we've seen it before. We know what it's going to feel like. We know what the experience is like, and we know what we need to do to get the job done. But at the same token, we also are all recognizing that we're going to watch out for each other. We're going to work as a team. We're going to back each other up with our crew coordination and not allow the complacency that could come with experience to cause problems. So the experience is great. It's really important. It helps us design our mission as most efficiently and as effectively as possible. But it's also something we watch out for and want to make sure we keep a balance between that and focusing on being very meticulous and thorough in our planning and in our operations.
The content of this mission has been through some changes since you first started training for it.
Yes.
Tell us how that's impacted the training flow and the adjustments the crew has had to make.
Well, it's we started out as an 8-day mission. We're just going to go up, dock with space station, offload some payloads, and using robotic procedures, doing a lot of transfer, and basically leave station in the best logistics state possible, because when we were originally assigned, we were going to be the very last shuttle mission, so we wanted to leave space station in the best state possible. It's since evolved to, they've added a couple of spacewalks to our flight. So what we've had to do is lengthen the mission from 8 days to 11 days nominal, with a +1 if we need it. We're having to pick up and train those 2 spacewalks, which we hadn't been training for before. We've also added a whole bunch of robotics that go along with that. As a result of that, I've had to move crew members into different tasks to make the timeline fit to make that happen. So we're in the process of going through that. We had to redo our training. We had to take added about another 6-week slip to deal with all the spacewalk training. So the biggest impact, I think, to the whole training flow has been the number of NBLs, neutral buoyancy lab runs, in the water to train for those spacewalks. So, but we've got a good plan in place. We have a good schedule in place, and we've worked out all those details. And so it's just going to take us a little bit longer to get there, but we still have a good plan and feel pretty comfortable with what we're doing.
How would you characterize the contributions of the thousands of people that work behind the scenes for every mission to ensure the success of the mission and the safety of the crew. What do you say about their contribution?
Well, I guess what I would say is that coming into this mission, my theme with my crew and with everybody I talk to is, particularly as the shuttle program winds down, is that this mission and this flight is not about us. It's not about the crew. We're the people that are fortunate enough to get to go execute the mission, from space, if you will. But we have a huge team of mission control folks that are executing on the ground and engineering support. We have a huge team all across at the various human spaceflight centers, whether it be Michoud at the tank assembly. We have processing. We have Huntsville, Stennis that's doing the engine testing. Huntsville that's managing the external tank and the solid rocket boosters. We have multiple contractors that are working all this, and we have the space shuttle program that's managing as well as the space station program, and all of these companies involved. And it's really all about the huge team. So when you see a mission go off, you're seeing the astronauts maybe on TV, but that's not what the mission's about. The mission is really about those thousands of people. And so what I emphasize, it's not about us, it's about this team. And when you watch something, it's similar to when I was a test pilot, only in smaller teams. When you watch this team of diverse people across the country come together and put together something as unbelievably complex as a space mission, put it all together and then execute it and make it look easy, so the public watching thinks, oh, this is really, this is routine, this is easy. Well, those of us that are in it know it's anything but it's all this preparation and the dedication of folks that really make this happen. When I first got here to Johnson Space Center almost 15 years ago, I remember walking around the center, and I was after I'd been here about 6 months, I got to know a lot of people around the center, and I was very struck by the workforce here, as well as Kennedy Space Center, we were just there, and all the other centers I've been to, is how motivated everybody is. People are not here for the money. People are here because it's about something that's much, much bigger than them, and that makes it a really exciting place to work. So when we go and execute a robotics task or do something on orbit, what I'm really thinking is, well, we're executing it, but we're just showing the final product, and it represents all of these thousands of people. So I feel like when we fly, we're there representing all these other people, and it's not about us.
If your launch schedule holds, you're scheduled to be on board Space Station right around the time of the 10th anniversary of the arrival of Expedition 1, the crew that established continuous human presence on ISS. Discuss the significance of their milestone and the station's importance to the future of spaceflight.
Well, it's interesting when I look back to when that happened. That they went up there. I'd only been here a few years when Expedition 1 and Shep's crew went up there, and I was also involved in the very early space station assembly. I delivered the airlock on my first flight to space station, and I remember going up to space station then, and it had just barely started. And I remember thinking about all of the missions and all the components we still had to fly up there to fully build this thing out. And at times it seemed like we were never going to get there. It was just, there were so many missions. Every time we launched a mission, we'd have little things we have to work at. Every time they put a component on space station, one thing you learn when you go from the engineering or design phase, assembly and build, to actually operations is a module never works like you think it's going to, and you always get surprised. And that's just the nature of the business, because it's one of those things that's never been done before, and every time we're learning. When I look back at it now and see this fully assembled space station operating with 6 people, which we just went to last year, and doing all the science and stuff like that, I'm just amazed at what this big team has accomplished, and I'm really excited about what it's going to accomplish in the future. So it's for me, getting an opportunity to go up there again, which I never thought was going to happen, and see this fully assembled space station I've worked on most of my professional career here at NASA is just going to be really something fantastic to see, and I hope the rest of the world appreciates what we have. I know that the future of space station has not been written, but I also know that space station is going to contribute things we have no idea of today, and we've already seen that.
Tell us about the key objectives, if you would, of STS-133.
Our primary objective, the way I describe it for people in a nutshell, is to basically leave space station in the best possible shape for the next era, which is the era when we're no longer flying space shuttles and have huge amounts of upmass we can take up to space station. So along those lines, what we're doing is we're delivering logistics and supplies and doing some maintenance and some outfitting to leave it in the best condition we can with what we can carry up. So we're carrying up a full mid-deck of some payloads, with some science payloads and logistics payloads. In our payload bay, we have a PMM, which stands for Permanent Multi-Purpose Module. It's essentially an MPLM, which is a pressurized cargo carrier that we've been using on space station for several years to haul logistics up and down. The difference being is this MPLM has been modified into this PMM, and what they've done is they've put additional micrometeorite shielding up in it and a few other internal modifications. And the objective is we're going to put it on space station robotically, and we're going to leave it there. So not only will it be full of supplies for the space station, it will also serve in the future as a closet for space station for stowage, which is something that they always need up on space station. We're always short of, and so we're going to put it up there and leave it. The other thing we're carrying is something called an express logistics carrier. What that is it's a big external pallet, and it has several places for payloads or spares for the external components on space station. And in fact, our ELC is going to have a large radiator, an ammonia radiator that we use to reject heat from all of our electrical boxes on the outside of space station. So we're carrying a spare one in case one breaks on space station. They can install it later. And we're going to take that carrier and we're going to install it on the space station truss. And so those are the things in our payload bay. For the spacewalks themselves, we're doing several tasks of outfitting the space station, doing some what we call cats and dogs cleanup work, taking care of some insulation issues, working on some various components that need to be doing. And it's just a whole list of kind of cats and dogs tasks that we'll be doing in addition.
And as mission commander, tell us about what your key responsibilities will be for Ascent and then on orbit too.
Well, my primary job as commander, as I see it, is I'm responsible for the overall, the training, the safety is my number one, safety of the crew, and the conduct of the mission, the accomplishment of the mission objectives. That's my global responsibility, and that's what's most important. So in that context, my primary job, as I see it, is to enable the rest of the crew to do their jobs. And I try to make sure that the specific things are generally speaking being done by them and not by me. I have other people doing the robotics, I have other people doing the spacewalks. Now, specifically, with only a 6-person crew or even a 7-person crew, it's not like I can go up there and just let everybody else do the work. They still need me to do work too. And so on Ascent, I'll be in the left seat, and I have, again, responsibility for conduct of the Ascent. So I run the flow, I run the Ascent. I have specific responsibilities with several of the systems, like the computers and the life support systems and the flight control system. I'm primarily responsible for all the navigation, guidance, and control. Where we're going, how we're doing on our trajectories. What do we do if we have 0, 1, 2, or 3 engines out? Those sorts of failures, dealing with those. And making sure we go through our procedures effectively and efficiently and basically run the crew through those procedures. Same thing on entry, except I'm coming in and in the end on entry I'll be doing the manual landing of the orbiter. On orbit, on flight day 2, where we inspect the outside of the orbiter using the orbiter boom sensor system to look at the thermal protection system and make sure it's healthy, and again before deorbit. I'm one of the 3 space shuttle robotic arm operators, so along with my pilot Eric Bowe and mission specialist Al Drew, the 3 of us will be doing all the space shuttle robotics work to inspect the orbiter, as well as space shuttle robotics work in support of the spacewalks and activities while we're docked at the space station. For rendezvous, I do the manual phase where I take over the vehicle at about 2,000 feet away from space station, fly up to a position underneath the space station, do something called a RPM, rotational pitch maneuver, or R-bar pitch maneuver, which basically is just a 360 backflip so that the space station crew can take pictures of our tiles and make sure they're okay from a thermal protection system standpoint. Then I'll fly around in front of the vehicle and manually fly in to do the docking. So that's the other thing that I do on orbit. During the dock phase, I'll be involved with transfer, as is the rest of the crew, robotics, supporting all of the spacewalks, but I'm not doing the spacewalks, and a whole bunch of other things that are on the timeline. So that's kind of in a nutshell what I'm doing.
Okay. You and your crew are also scheduled to deliver R2, or Robonaut 2, to the station.
Mm-hmm.
Can you tell us about what you know about R2 and what its purpose and is on station and how it will be utilized?
Well, R2 or Robonaut is kind of a joint venture between NASA and General Motors, and what it really is a technology demonstrator of a humanoid-like robot. Has articulating joints, hands that move just like your hands do, and elbow joints and shoulder joints. It's just a torso on up. It has cameras for views, and it's going up on a pallet in our PMM, and probably it won't get installed and checked out while we're there, but probably within the next 6 months they'll pull it out and put it in a rack and hook it all up. And it's designed to be controlled, by the crew or remotely from the ground. And it's just a kind of a first human-like android kind of thing, where they're going to technology demonstrate and do various tasks, probably mechanical tasks at first, check motion. They want to see, they've been tested on the ground, but they want to see how it's going to work in a zero-G environment. And then as far as what we'll do in the future, a big part of it is going to be, well, what tasks are best for a robot to do? Obviously, we know that the best task for a computer to do, that a computer can do better than humans, is repetitive math tasks and things like that we tend to, you can't do all day, every day, but a computer can and won't bother them. So looking for tasks where a robot can assist humans up in space or act robotically on their own. So it'll be a technology demonstrator as far as what all objectives it will eventually get. That's one of those things I think we're going to learn as we go, as they operate it, and try various different things. And I would imagine that it will take us to places we couldn't imagine. So it'll be interesting to watch how that develops and what we learn from it, and where it ends up being. Because I suspect that how we think we're going to operate it right now is probably wrong, because we just don't know. We haven't done it before.
Okay. On the same day that you dock to station, the crew is scheduled to move the ELC-4 out of Discovery's payload bay and attach it to the station temporarily. Can you walk us through that process and tell us who's going to be involved and who's going to be doing what?
Sure. That's going to make actually our flight day 3, our docking day, a very challenging day, a very busy day. So we're gonna dock. Once we dock, and it's about a 6-hour process from starting the rendezvous till docking, maybe a little bit more. Once we dock, we'll do pressure and leak checks, and once those are good, we'll open the hatches. We'll get together, do a quick safety briefing, and then immediately we're going to jump into this ELC-4 task. And what's unique about it is it goes out on S3, which is way out on the starboard side of the truss. To get it there is a little bit tricky, though. We can't pull it out of the payload bay with a shuttle arm because the station structure is in the way. So the space station arm is actually going to reach in, and as soon as after we dock, I have a couple of the shuttle crew members are going to go over, work on the space station arm. I mentioned that my pilot Eric, myself, and Al Drew are the shuttle arm operators. Well, Mike, Nicole, and Tim are the station arm operators. And in this case, Nicole and Tim are going to go over, and they're going to jump on the space station arm. And I'm going to have Eric and Al on the space shuttle arm. So what happens is Nicole and Tim will use the space station arm, pull it out of the payload bay, get it to a position. Then Eric and Al are going to grapple it. So now you're double grapple. You're going to grapple it with the shuttle arm. So we're grappled on two sides. Then they're going to let go with the space station arm, and they actually have to reposition the arm in another location and do what's called a walk-off. The space station has end effectors on both ends, and so it can actually it's fixed on one end and moving on the other end. They can actually go to a new grapple location, grapple it twice, and release this end, walk it closer to the location they need to go to, and then after they do this walk-off, they'll re-grab that logistics carrier, and then Tim and Eric and Al will release, and then they will maneuver it and finally put it in place on space station using the space station arm. So we call it a double walk-off, so it's a complex choreography between the two arms and the two crews to do that, and it'll take quite a while, all the way up till sleep time to do it.
Okay. What level of involvement will the station crew have in the docked operations, and how critical are they to the success of completing the mission?
Station crew is critical. My philosophy and the way I've always worked, and pretty much every crew does, is when we dock and we open hatches, we consider ourselves one crew, not two crews. We're very, very integrated in our operations because they're so complex and there's so much going on. For example, when we do our first spacewalks, which has a lot of space station robotic arm activity associated with it, we'll have a space station, our SSRMS space station robotic arm team is going to consist of a shuttle and a station crew member. It's going to be Mike Barrett and Shannon Walker, who's already up on space station, working together to operate that space station arm. With our transfer activities, with all of the work we do on the spacewalks, with the suit prep and EVA preparations and things like that, the space station crew is intimately involved. My other philosophy with operations on space station is we're going to come with the shuttle crew comes as with the most recent knowledge and training in specific tasks. But the space station crew has the benefit of having the most experience on the actual space station equipment. So what I try to do is I try to team the shuttle crew, which has this task knowledge, with the space station crew, which has the expertise. Team them together, have them work together, and now you have the best of both worlds. And hopefully between the two of them, you get to end up with a cohesive team that has, where 1 + 1 is more than 2, it's 3 or 4, and let them work as a team. So we're intimately involved, back and forth. I think of us as one crew rather than two crew, and that philosophy works pretty well.
Much the same as you did with explaining how to get the ELC-4 out of the payload bay and attached to the station. Could you do the same with the PMM and tell us specifically where it's going to be attached to?
It's a little bit simpler robotically than what we did for the ELC. Mike and Tim are going to go over on this space station arm, and they're going to grapple the PMM, which was sitting in our payload bay. Prior to doing that, we're actually going to hand off our orbiter boom sensor system. And the reason we're doing that is there's a couple reasons. One is the OBSS, as we call it, sits right along the edge of the payload bay. And we want to move it out of the way so that we have more clearance as we pull this really big payload out of the payload bay lateral, because we only have a few inches of clearance as we pull it out. So we're going to do this handoff of OBSS, and essentially what happens is we grapple that OBSS with a space station arm, pull it out, put it into position. We do a double grapple with the shuttle arm, grab it, and then the space station arm releases, and then we maneuver that orbital boom sensor system out of the way and in a good viewing location for EVAs and for PMM and a bunch of other robotics we're going to do. Then they're going to go in and they're going to grab that PMM, they're going to pull it out of the payload bay, and we're going to stick it on node 1 nadir, which is we docked to node 2 now. Node 1 is the furthest one, and that's where we used to dock to before we got all of the other equipment up there. Or we used to dock at the front end of the lab, and now we dock from the node 2. But node 1 is where we used to always put the MPLMs until recently. But we're going to put it there, node 1 nadir, so it'll be in a permanent location up there. So robotically just comes out of the payload bay. They move it aft on the space station and stick it on node 1. Once we get it attached there, they'll release it with the arm once it's attached with the common berthing mechanism system. And we'll do pressure checks overnight. We'll make sure that it's holding good pressure. And then the next day, Eric Bowe is going to go over there with Scott Kelly, again, an ISS and a shuttle crew member, and they're going to do what's called vestibule outfitting. And that's where they open the hatches, they make connections, power and data connections between the module and the space station, turn everything on, turn the fans on, get it activated, get the final hatch open so that we can start doing the logistics and start using it as stowage.
this is your first mission since STS 121. It's been a while. You've been chief of the astronaut office for you were there for 3 years. What's it been like getting back into this training thing, this training flow thing? Has it been difficult, or is it kind of like a muscle memory? Once you learn how to ride it, you never forget.
Well, it's been interesting because after I flew STS 121 and I got offered the astronaut office chief position, I took that with the intent of never flying again. I thought I was done flying. As it turns out, other people had different plans for me. So when I got assigned, for the last 3 years as chief, I was involved in every single space station and space shuttle mission, intimately, except I was working it as a manager and working it really from the ground side during the execution of the missions and kind of keeping an eye on the training. But I was enabling other crews to do these jobs, not me. And so I kind of, and other than going in the simulator once in a while as an instructor pilot, just to see how crews were doing and providing some feedback, as they're going through their training, or maybe upgrading a new space shuttle commander or something, I wasn't at all staying current in the simulator and current in the latest things. And so when I got assigned to this flight, I kind of had to go in to start over, and I was wondering myself, I wonder how much I remember or how much I'm not going to. But most of it is very similar to what I did before, so most of it came back. I was a little rusty on some things, but it all came back pretty quickly. But believe it or not, in 3 years, and we've been doing flying shuttles for almost 30 years now, it's amazing how much stuff changes in 3 years. The little things that change, and sometimes I find myself, well, we need to do this because of, for example, we were just down at Kennedy Space Center looking at the orbiter, and I was looking at some switches on the aft panel that controlled some payload bay lights, and said, well, yeah, I mean, this controls this light, and then the folks at Kennedy Space Center were telling me, oh, well, we removed those lights, 2 or 3 flows ago, like a year ago, and I didn't even realize they'd removed the lights. And so some of those things have changed, or sometimes I'll remember, well, we did it this way, and then I'll realize, well, no, that was 6 years ago. We don't do it that way anymore. So I just haven't been having to brush up on or relearn those things that have changed. But for the most part, it's all come back to me. And I have a great crew that's experienced, and they watch out for me and make sure they get me up to speed with the latest. So it's been a few challenges there, but for the most part, it's been a really fun transition. And in terms of stress, this is a lot less stressful than being chief of the office.
I can imagine so.
Oh, there's no comparison. None at all.
Okay. After your work on station is complete, you'll undock from station and prepare for your trip back to Earth. It might be one of the last opportunities that anybody gets a chance to see station from that vantage point from inside of a shuttle. As you sit here today trying to imagine what that's going to be like, what comes to your mind?
What comes to my mind is, and I tell the new astronauts when I was chief, before they're going up on their first flights, I tell them that there's some things you should do when you're up there. Obviously, you're up there to accomplish an objective, to accomplish the mission, and that's the only reason you're really going. You're not going to experience. We don't fly into space to experience space. It's not a tourist ride. It's not a joyride. We're there to accomplish an objective, and that's the satisfaction, is getting difficult objectives done. But a byproduct going up there is you do get to experience it. One of the things I tell new astronauts is make some memories in your mind. Remember doing this. Remember what it was like to do this. Remember what it looked like the first time you looked at the Earth. Remember what it looked like when you looked at something significant to you, like your hometown or something like that. And so I think when we undock and fly around space station, what I'll be trying to do is remembering what it looks like, capture some moments that I won't ever forget. Because we can capture it on film, and we got great cameras, and we can get great pictures, and we will get great pictures. But that still doesn't do it justice, what it actually is when you actually see it. Every time I've come back from a space flight, usually about 2 weeks later, I wake up asking myself, was I really there? Because it's so different than being on Earth. And I can't even describe it in words, but it's just so unique. So what I will be trying to do as we undock, besides making sure we do it right and and safely and successfully is try to capture that mental picture of what space station looks like. I'm really looking forward to seeing the space station, which is at least twice the size as it was last time I saw it, and to see it all built up after these 10 years of wondering whether, when is it, are we going to get this done, can we get this done? All of these modules can't possibly fit together. That was my thinking, because we never end-to-end tested the whole space station, because we'd had elements up there while other elements were still being built. And for you to go up the first time and everything put together still just amazes me. And so I'm looking forward to seeing that.
This mission is scheduled right now to be one of the final shuttle flights. What does it mean to you to have had a part in the space shuttle program? It's something that's considered an American institution.
Well, I consider myself very fortunate, and I consider a privilege to be part of this team, the space shuttle. When I think space shuttle, I don't think about a vehicle, I think about team, I think about people. That's what it's really about. The space shuttle is an incredible vehicle. First started flying 30 years ago, but even if you look at today, I'm still amazed at the technology to build something that could carry this much payload into orbit and take off vertically, land on a runway, serve as a rocket ship, an orbiting laboratory, a docking ship, a robotics platform, and land like an airplane. I mean, that's pretty incredible. And so that's, I consider an honor to be a part of it, to be involved essentially with the last half of the space shuttle program and seeing all this happen, and then to take this space shuttle and do things with it we never intended to do, and then eventually build this fantastic space station that is kind of the legacy of the space shuttle that's going to live beyond the shuttle. That's what I think about it. So it's important to me. I feel very privileged. I think it's a unique part in our history that I feel very privileged to be a part of, much like probably the folks felt like that were involved in Apollo or Gemini or Mercury or any big program like that.
You've flown on Discovery several times, I believe.
I've flown on Discovery twice. And one more to come here.
Okay. It's the most accomplished orbiter in the fleet. If you had to compile a list of just based on off the top of your head knowledge of what you know about what Discovery has done, if you had to compile a list of its greatest hits, so to speak, tell me which missions or events would have to be on that list.
Well, there's a lot. The ones I'll focus on, though, are the ones that I think of. And there's, it's done some of the deployment of the great observatories and things like that. And but what I think about is it's flown all three of the return to flight missions. And probably the most difficult parts in the shuttle program were recovering from the two accidents we had. And those were very traumatic times. I wasn't here for Challenger, but talking to the folks that were around, I know how traumatic that was. I was here in the middle of the whole Columbia thing and recovered from that, and I actually flew the second return to flight test mission after Columbia. In those missions, recovering the program from a disaster and getting it back on track again, I think that's what Discovery will be remembered for, at least in my mind, as the most significant, because this deploying, it's flown all kinds of fantastic missions. I mean, I also got to fly it with as a pilot on a flight with John Glenn, and that was a really neat flight to be on. But those return to flight test missions, by accomplishing those successfully into unknown after an accident and uncertainty on whether, and uncertainty not just in have we made the repairs necessary to continue flying this as safe as we can, but also to get our confidence back after a major accident that we could continue, we can still operate this vehicle safely and successfully, and we can still do our job. Those missions were turning points because when they were successful, they allowed us to continue the space shuttle program. In the case of Columbia, they allowed us to continue space station assembly and complete space station assembly. So those are the missions in my mind that are the most significant about Discovery. But Discovery, it seems like Discovery's been around and hit almost every major thing that's happened in the shuttle program, and it's just, it's just luck of the draw. It just works out that way because of the processing flow. But it's interesting that Discovery has done all those things, which I think is why it's really appropriate. I think the Discovery ends up at the Smithsonian when this is all over.
How would you characterize what Space Shuttle has meant to the advancement of human space exploration?
Wow. I think when you look back, first of all, I think the model of launching like a rocket, landing like an airplane, I think that model will be used in the future. And I think and I don't know how many years in the future that's really going to be, 50 years, 100 years, you pick your time. I think someday we'll be going in and out of low Earth orbit in that manner, and using our infrastructure of runways, and taking off and landing and going into space that way. So that model will be used. What the space shuttle, I think, was way ahead of its time in that we developed that very early. We were able to do that successfully with the shuttle, but in the process of doing that, we ended up with a very complex vehicle, difficult to maintain, complex to operate, and that was a byproduct of that. So I think in the future we'll do that, but I think we'll learn all of these things from the shuttle, and the next vehicle we build hopefully will be simpler to operate, and we'll learn a lot from that. The way I describe the space shuttle to others is, when you really look at the space shuttle and its capability, it can do everything you can think of in space, except for one thing: it can't leave low Earth orbit. But it can do everything else. It can do robotics. It can do science. It can go dock. When you dock with a space station, in the end, you have to maintain a 3-inch corridor and 1 degree of attitude error, and you can easily fly the shuttle manually and maintain that. I mean, that's unbelievable for a 120-ton vehicle to be able to do that. So it can do everything except leave low Earth orbit. And so in terms of capabilities of a spacecraft in low Earth orbit, I don't think there's going to be another one that's ever going to match the versatility of the space shuttle, and I think that's the legacy. All the systems we developed and the things we've done on space station or on space shuttle have all had impacts in our society. I mean, literally any room you walk in, anything you do during the day, you can point at things in that room and say, that came out of the space program, this came from shuttle, this came from Apollo, this came from space station, and you can see it all around you. Now, the public's not real aware of all of that, but all of this stuff that we use, all of it came from it, and it's very hard to measure, but it's all there if you really think about it. And I think that's the legacy. I think the legacy is all these things came out of it, and people take all of those things for granted.